So now we are here at the Engineering Center of Yobi Inc. This is where our team of engineers develops and tests Yobi technology. Remember that Yobi technology is designed to work in real-world environments, so the ultimate vetting of our technology must take place in those real-world environments, in your home, in your family room, in your kitchen, in your car. And those are the places where there's going to be ambient noise, background noise, there's going to be near-field noise while you're trying to talk to your smartphone or smart speaker from the far field. Here at the Engineering Center, we also like to establish what we call figures of merit for our technology so that we can quantify the kind of performance that our technology is able to provide and how it compares to other technologies. So we have established procedures and protocols that go along with that, and here we have a setup that is the kind of environment we have in the laboratory to test our technology. So our technology is on this phone. Here we are comparing it to a Echo Dot, and the setup here is that we have multiple speakers that are all in the near field, because the thing we're trying to test here is how well our technology is able to detect, for example, somebody standing away in the far field, be able to recognize that person saying the wake word, and how that compares with the competing technology. So I have one of our audio engineers here. He is going to use some software that we've developed that randomly selects different sounds, such as television sounds, sounds from a vacuum cleaner, different appliances, etc., and it randomly plays them from different directions. And so let's do that. And so now let me try the technology. Let me just say Alexa. And now we're going to go into the far field, and my colleague there is going to also speak the same wake word from a much greater distance in the far field. Alexa. As you could hear and hopefully see, the Yobi technology was able to detect the wake word both in the case of where I was close, as well as in the case of my colleague who was much further. On the other hand, in comparison, the competing technology failed in this instance in both cases. Now we're going to go into the far field, and my colleague there is going to also speak the same wake word from a much greater distance in the far field. And now we're going to go into the far field, and my colleague there is going to also speak the same wake word from a much greater distance in the far field. Alexa.
Okay, in this example, what we're going to try to do is create an environment in a far field scenario where the voice of interest and the noise are coming from the same direction, so it makes it difficult to use solutions like beamforming to separate the voice from the noise. So first we'll just set the table and make sure that the Amazon device is actually working. We'll say Alexa. Of course she's on. And what we'll do is we'll turn on our application, which is running on a Samsung S7 2 microphone configuration, and we'll create an environment where there's some noise, and in this environment both solutions should recognize the wake word, so we'll introduce some noise. Alexa, and of course they both recognize the wake word. Now I'm going to go into the far field and try it again. We're up to go 50 feet. Alexa. And that's just a prime example on how, using artificial intelligence, we can track on a far field voice in near field scenarios.